So we're supposed to find the measure of the angle between these two vectors. So I put a formula. They have the same formula in the text, but I just Google image search the formula for it. So to find that angle, it's the cosine of the angle that equals this ratio. So we first want to compute the dot product of UV. In this case, the dot product of AB. And so that means we just multiply the first components. So 4 times -9, and then add the multiplication of the second component, -1 times 0. It's -36. And so the magnitude of u means how long the vector u is, and in this case we'll just call A the vector u for notation's sake. So it's using the Pythagorean theorem, that's just 4 squared plus -1 squared, and then take a square root. So that's square root is 17, and then the magnitude of the other vector, that one's going to be nice and easy because that's -9 squared plus 0 squared. So it gives us 81. The square root of 81 is just 9. Okay, then we can simplify that fraction. So cosine of our angle equals 36 divided by 9. 9 fits into 36 4 times, so that's -4 over the square root of 17. So this isn't like square root of 3 or square root of 2, so we're not going to be able to do our exact answer. Okay, exact answers of trig are when we have like the square root of 2 over 2 or the square root of 3 over 2, something like that. Square root of 17, that's not a trig value for cosine that we typically memorize. We don't have the exact value at our fingertips. So what we need to do is just use a calculator. Use inverse cosine or arc cosine on your calculator. So on mine, I'm pretty sure they wanted degrees when I looked at this. Oh, answer in radians. No, it says right there, radians. So on my calculator, I'm going to hit this button to change it to radians on my Windows calculator. And then I'm going to do -4. There's the negative sign. -4. Oh, it's going to be divided by the square root of 17. So I'm actually going to do the square root of 17 first. I'm going to copy that to my clipboard. And then I'm going to type in -4 divided by the square root of 17. And so that's what I need arc cosine of. I'm going to hit trig, second, and there's inverse cosine, arc cosine. So in radians, it looks to be 2.90 when we round to the second decimal place. Is it acute? So it's not as easy with radians to tell if it's acute. Acute means something that's less than 90 degrees. In radians, that's pi over 2, right? So if you convert pi over 2 to a decimal, there's pi divided by 2, that's 1.57. Our angle is above the 90 degrees in radians. It's above pi over 2. It's more obtuse than that is. So is it acute? We'd say no.